Hey everybody, welcome to Stoichiometry, the best lesson of the units. Here's the deal. Hopefully you've already taken notes on this. So we're going to kind of do this together, but I'm going to explain how this homework assignment works. This first page, all of it is having to do with hydrogen gas, oxygen gas, and water. So once we balance this equation and find these molar masses, you can use them for these three problems. The second page is a different equation, and you have to kind of balance this first and then go about solving it. Okay? Okay. So let's go ahead and get started here. The first step that you have to do in all of these is balance the equation. Now, this is a review from before, but I have one oxygen on this side. I have two oxygens on this side, so I'm going to give this a 2. Okay. I now have 4 hydrogens on this side, so I need to put a 2 over here, so I have 4 on this side. Cool. And now we're balanced. Awesome. The next step that I do, and you don't have to do this for every single reactant and product, but in this case, we're going to be using oxygen, hydrogen, and water. So I might as well just calculate all these right up front. So we're calculating molar masses. This was like 6.2 kind of stuff. And I look at hydrogen, and in a molecule of hydrogen, there are 2 hydrogen atoms, and each one of them weighs 1.008. And then I'm going to multiply these together. 2 times 1.008 is equal to 2.016. And that's it. That's the only atoms that are in that molecule, right? So that means my molar mass for hydrogen gas is 2.016 grams per mole. Okay, cool. Let's do that for oxygen. Oxygen gas is O2, so I'm going to put a 2 right here. And I look at my molar mass for oxygen, and it's 15.999. So I go 15.999. 2 times that is equal to 31.998. And then all I have to really do is, that's it. That's the only atom in there. You know what I mean? 31.998 grams per mole. That is my molar mass of oxygen. Now, water is slightly more complicated. For every molecule of water, there are 2 hydrogens and 1 oxygen, and each hydrogen weighs 1.008. And you already know what that equals. It's this number right here, right? So I'm just going to copy and paste that. And I know that each oxygen weighs 15.999. So I'm going to copy that and put it right here. And that means I have 15.999. And I add these two together. And if you want to use a calculator, you can. 2.016 plus 15.999 equals 18.015. And I'm knocking around right now. I'm just going to keep it nice and long. Bam. So what I did is I calculated the molar mass for all of my reactants and products, which I'm going to use down here. Now, in a question that's kind of isolated, where you don't have to use the same reactants and the same products, maybe that doesn't make sense. Maybe your question only asks for 2. So for instance, in this first one, it says, hey, you have oxygen gas and water. Well, then you only need to use this one and this one. You don't necessarily have to have hydrogen gas. But in the next one, we do use hydrogen gas, so might as well have all of them up here. Cool, cool. All right, now we can get into the real stoichiometry. So let's see here. If you start with 24 grams of oxygen gas, how many grams of water will be formed? Okay, so I'm going to start with 24 G, that's for grams, H2O. And you don't need to write of, and you don't need to write it. You should actually just write it kind of like how I just did right there. Just G, H2O. And we want to know how many G, I'm sorry, this is actually G of O2, excuse me. It says we start with 24 grams of oxygen gas. How many grams of water will we have? Okay, I write down what I have, what I want. So now I can start to fill in some stuff here. I can say, hey, I start with 24 grams of O2. How many grams of H2O will I get? Okay, okay. Now, if you have your notes open, it will kind of give you the roadmap. But basically, you cannot go from grams of O2 to grams of water, to grams like mass of one thing to mass of another things. You have to go into moles. The trick of stoichiometry is always get into moles and out of moles. So the first thing I'm going to say is I'm going to say, hey, I have grams O2, and I know that the molar mass is grams per mole, so I can do that. But I'm still in oxygen, and I need to get into water. So that means what's on top here goes on the bottom here, and then I can do a mole to mole ratio like that. Okay, moles of oxygen, moles of water. And again, I'm just focusing on units right now. Then I know that whatever's on top here goes on the bottom of the next one, and I can get to grams of water, okay? So if I have set this up correctly, my units will cancel out. Let's go ahead and check out, see if that works. Grams of O2, grams of O2, moles of O2, moles of O2, moles H2O, moles of H2O. I'm left with grams of water. I have grams of water. Dopey dope, no joke. That's a new one. I just came up with it. All right. So now we are ready to put in some numbers. So this first one right here is I have a grams and a mole of oxygen. So over here, this is my molar mass of oxygen. I calculated it already. I did my side hustle. It's 31.998 grams per 1 mole. Okay, so that means it's 31.998 grams for every 1 mole. The number always goes next to the grams, and on this case, it's in the bottom. Cool. Now I have moles of water and moles of oxygen. And on a mole to mole ratio, I use the balanced equation. So right here, I have 1 O2. So I'm looking at the number before the O2 and I see it's a 1. So that means this gets a 1. And then moles of O2, I have a 2 here. So I'm going to put a 2 here. Okay. Now I'm in moles of water and I need to get into grams of water. And to do that, I'm going to use the molar mass of water, which I calculated to be 18.015 grams for every 1 mole. So that means 18.015 grams for every 1 mole. Cool, cool. Now I'm ready to do some math. And what I'm going to do is I'm going to multiply everything on top. 24 times 1 times 2 times 18.015. Enter. You must press enter when you get to the end of the top. And then divided by 31.998. Enter. Divided by 1 equals, divided by 1 equals 27 point. And you know what? This only has 2 significant figures, so my answer can only have two significant figures. So my answer for this one is 27 grams of water.